Okay, so today we're going to graph absolute value functions. We have looked at absolute value equations and inequalities before, but we've never graphed them. Okay, here is the form of an absolute value function. Y equals A, absolute value of x minus h, absolute value plus k. A, h, and k are going to do specific things to the graph. They're going to be specific transformations, whether it's flipping the graph, moving it left or right, up or down. They're just going to do different things to the graph, and we're not going to talk about that yet. Eventually we will talk about the transformations, but today we're just going to graph the absolute value function. So the first, let me just say this. An absolute value function is going to make a V. Okay, so we've graphed lines so far. Now an absolute value function is going to make a V. So there's going to be a vertex. The vertex is the point of the V. Okay, the point. So we're going to find the vertex. And how do we find the vertex? We're going to take the inside of our absolute value symbols and we're going to set it equal to 0. Sometimes you'll have to solve, sometimes you won't. So like in this first example, we just have an x inside the absolute value symbols, so we're going to set that equal to 0. Okay, we didn't have to solve for x there because x was the only thing inside the absolute value symbols. Now this is called the parent function. It's the most basic absolute value function. It's just the absolute value of x. Okay, for a line, the parent function is y equals x. So just the most basic line. So next, so that we did step number 1. Step number 2, we're going to make a table of 5 values. And how do we know which values? You're going to put the vertex in the middle of your table. Why? Because we want points on this side of the vertex and we want points on this side of the vertex. Okay, on both sides of the vertex so that we get the V. So that's why we put the vertex in the middle, and now we're going to pick 2 points that are less than 0 and 2 points that are greater than 0. Okay. Technically, you could pick any points. Usually, we just pick the points that are right next to that number. So the vertex goes in the middle of your table. It's number 3, plot points to make a V-shaped graph. Well, we have to find the values first. So how do we do that? Anytime we know x, we plug it into the function and solve for y. So let's do that. Let's plug in -2. Well, what is the absolute value of -2? Positive 2. Okay. So absolute value of x. So absolute value of -1 is positive 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And the absolute value of 2 is 2. So let's plot those points. I always like to start with my vertex. Okay, -1 up 1 and -2 up 2. Now, something that you'll notice is you're always going to see symmetry, because if your vertex is in the middle and it makes a V, you'll always see symmetry. So if you don't get 2, 1, 0, 1, 2 and you don't see that symmetry there, then you know that you made a mistake somewhere, and that mistake is probably that you don't have the vertex in the middle of the table. That's probably the mistake that you made. So here's my absolute value function. We want to put arrows on the ends because just because we stopped graphing doesn't mean that the function stops. And then we want to find the domain and the range. So the domain is talking about the x values. For all of our absolute value functions, the domain is always going to be all reals because it extends on forever in both directions. Okay? But for the range is describing the y values of your function. So what's the smallest y value on my graph? 0. Are they all above or below 0? Above. So y is greater than or equal to 0. Okay, so you're always going to use the y value of your vertex for the range, because all your values are going to be above that value or below that value, and they'll always be able to be equal. So it's always going to be greater than or equal to or less than or equal to. Any questions? All right, next one is very similar, except where you have a -1 times the absolute value. So again, we take the inside of the absolute value symbols and we set it equal to 0. and that is the x value of your vertex. So we'll make a table of values, and we're always going to put that in the middle. Okay, so now we want to pick two values on the left, two values on the right, two values that are smaller than 0, two values that are bigger than 0, and now let's plug that into our function. So we have -1 times the absolute value of -2. So, following order of operations, we take the absolute value of the absolute value of -2 first, and we get -1 times 2, which is -2. Let's do the same thing again. Negative times the absolute value of -1. So we have -1, and the absolute value of -1 is +1. So +1 times -1 is -1. Negative times the absolute value of 0 is just 0. We have -1 times the absolute value of 1, which is just -1, right? Because that's 1, and then we multiply it by a negative. And then -1 times the absolute value of 2 is -2. Any questions on how I got those numbers? Okay, let's plot them. I always like to start with my vertex. Okay, you can see the symmetry here, so that's good. That means I probably have the vertex in the middle. So -1, -1, -1, and then -2, -2. And then I actually just use my symmetry to graph the other two. And there's my absolute value function. And then we want to state the domain and range. Domain is all reals. It's always going to be all reals for the ones that we're going to look at today. And then the range, all of my y values are below, so less than or equal to what value? They're all below what value? 0. Yep, the y value of your vertex is 0. They're all less than or equal to 0. Yeah.
What is the domain?
Domain is all reals. All real numbers. So then you just draw, yeah. It's kind of like a capital R, but with 2 lines. Yep. All right, questions? Yes. I know it's kind of dark, hard to see. I don't think it goes brighter, but does it help for me to zoom in at all? Oh, let's have it turn off. Does that help? A little bit? Well, you guys can't see your papers now, can you?
No, we can't.
Are you sure?
Yeah.
Okay. Yeah. Yep. All right. So we have 3 more examples we'll do together, and then 1 for you guys to try. And this is the end of our chapter 3 notes. So.
And then we have a test.
Yep, and then we have a test next week, next Thursday, Friday. Yep. All right. First step, look at the inside of your absolute value symbols. Are you guys sure you can see?
Yeah.
Okay. All right, don't fall asleep on me. All right, so take the inside, set it equal to 0. This is the first one where we actually have to solve for x. So let's subtract 2 from both sides, and we get x equals -2. And that is going to go in the middle of my table because that's the x value of my vertex. Okay? We need points on both sides of the vertex because we need to make the v. So we'll go -4, -3, -2, -1, and 0. And now let's plug those in. So the absolute value of -4 plus 2, okay, order of operations, well, -4 plus 2 is -2, and the absolute value of -2 is +2. All right, -3 plus 2 is -1, and then we want to take the absolute value of -1 to get +1. All right, -2 plus 2 is 0, so the absolute value of 0 is just 0. -1 plus 2 is absolute value of 1, which is just 1. And that's good because you can see the symmetry here. And then 0 plus 2 is the absolute value of 2, and we get 2, and you can see the symmetry there, so that's a good thing.
Why isn't 1 negative? Like,
right here,
Yeah.
because you take the absolute value of it, and the absolute value of anything is always going to be positive.
Okay.
Yep, and then same thing here. Absolute value of negative 1 will be positive 1.
Okay.
Yep. All right, so let's graph those points. I always start with the vertex, negative 2, 0. So it's on your x-axis. Negative 3 up 1. Negative 4 up 2. And then I just use symmetry to graph my other points. All right, so negative 1 up 1, 0 up 2. So, okay, draw arrows. Just because we stop graphing doesn't mean the graph stops. And then let's list our domain and range. Domain is always going to be all real numbers. Okay, range, you always want to look at the y value of your vertex for the range. Okay, are they above or below 0 here? Above, yep. So your range, y is greater than or equal to 0. And your vertex is always a closed circle, so it's always going to be equal to. Greater than or equal to, less than or equal to. All right. The inside of the absolute value symbols here is x. So that's really nice because we just set that equal to 0, and we get x equals 0. So that goes in the middle of my table. So we'll go negative 2, negative 1, 0, 1, and 2. And let's plug those x values in and solve for y. So the absolute value of negative 2 minus 3. So let's actually take the absolute value, and that's positive 2 minus 3, which is negative 1. Absolute value of negative 1 minus 3, that's positive 1 minus 3, which is negative 2. Absolute value of 0 minus 3, so that's 0 minus 3, which is negative 3. You guys probably can see a pattern in your y values. There will always be a pattern. Absolute value of 1 minus 3, so that's negative 2, which is good because, right, we should get symmetry since it's a v. And then we should get negative 1 for the last one. So let's see if we do. Absolute value of 2 is 2. 2 minus 3 is negative 1. Perfect. We see that symmetry there, which is good. So that means we did it correctly. All right, so let's graph that. 0, negative 3. Negative 1, negative 2. Negative 2, negative 1. And there's my absolute value function. Your absolute value functions will always make a V. If they make a line, you probably didn't get the vertex in the middle of your table. Okay? So then you would want to go back and check to make sure you have the correct vertex. All right, any questions? Oh, domain and range. Domain is always all reals. Range. All of your y values are above, so greater than or equal to, and you can always look at your table at the vertex. They're all greater than or equal to negative 3. Okay? They're all above negative 3. So greater than or equal to negative 3.
What would the domain and range be for the first one?
Domain is all reals. Range y is greater than or equal to 0. On the front page, you mean?
No.
Oh, right here? Yeah, all reals. All right, last one, and then I'm going to have you guys try one. Use a graphing calculator for example E only. Okay, we're going to do it by hand, and then I'm going to show you guys how to use the graphing calculator. Okay, so take the inside of the absolute value symbols only, which is 3x minus 6, and set the inside equal to 0. Okay. Now solve for x. So 3x equals 6. Divide both sides by 3, and we get x equals 2. So 2 needs to go in the middle of my table. So now we'll go 0, 1, 2, 3, and 4 for the x values. And let's plug those in for x. I'm going to use the work over here so that I can write down my work. So 0. So negative 2 times the absolute value of 3 times 0 minus 6. Absolute value plus 5. So 3 times 0 is 0. 0 minus 6 is negative 6. So So we have negative 2 times the absolute value of negative 6 plus 5. Okay. Well, the absolute value of negative 6 is positive 6. So negative 2 times positive 6 plus 5. So negative 2 times positive 6 is negative 12. And negative 12 plus 5 is negative 7. So that was a bit of work. You just have to make sure that you follow order of operations. All right, next one. Let's plug in 1. Negative 2. Well, 3 times 1 is 3. And 3 minus 6 is negative 3. So the absolute value of negative 3 is positive 3. So let's multiply that by negative 2 to get negative 6. And negative 6 plus 5 is negative 1. All right, let's plug in 2. So 3 times 2 is 6. 6 minus 6 is 0. So now we get 0 plus 5 is 5. Now we should see symmetry here, so we better get negative 1 for the next one. If you don't, then we probably didn't put the vertex in the middle of the table. So negative 2 times the absolute value. 3 times 3 is 9. 9 minus 6 is 3. So the absolute value of 3 is 3. 3 times negative 2 is negative 6. Negative 6 plus 5 is negative 1. That's a good sign. That means we probably got the vertex in the middle of the table. And then we should get a negative 7 here. So negative 2 times the absolute value of 3 times 4 is 12. Minus 6 is 6. So negative 2 times 6 is negative 12. Negative 12 plus 5 is negative 7. Whew, that was a little bit of work. Okay, so 2, 5. I just always plot my vertex first. Okay. You don't have to, though. You can just go in order of the table if you want to. 1, negative 1, and 0, negative 7. Domain is all reals. It always will be for this class. And then range. All of your y values are below, right, less than or equal to the y value of your vertex, which is at 5. Right? So here's your y value at 5, and all the y values are less than or equal to 5. Bless you. All right, any questions before I show you how to graph these on a calculator? Okay, the reason I'm showing you on a calculator is because you guys bought the calculators, so I want to make sure that we use them, right? If you're gonna buy them, I want to show you as much on the calculators as possible. So, if you guys have a calculator, take one out. If you don't, borrow one of mine, either from the black bin or from the charging station over there. Okay, so get a calculator, whether it's yours or you're borrowing one of mine. Okay, so the graphing function, you're going to hit y equals. Let's plug in this the one that we just did, okay, and see if ours is correct. So now we're going to type in this function. So we're going to type in negative 2. Make sure you guys use the negative sign down here. Negative 2. Now we want to get the absolute value symbol, so here's how you're going to do that. And I will post a video of this on Google Classroom, of the calculator portion, so that if you want to go back and need a refresher, then you can watch how to do it again. Okay, so hit math, arrow to the right once, so that you're on NUM for number, and then ABS stands for absolute value, so you're gonna hit enter. Again, math, arrow to the right to number, and then hit enter. Right? Inside the absolute value symbols, we want 3x minus 6. X is right here. Right next to the green alpha button. Right here. Now we need to arrow to the right so that we get outside of the absolute value symbols. And now we need a plus 5. All right, now we can graph it. You guys don't need to do this, but I need to change my window. So you can hit graph, and we will be able to see the graph of our absolute value function. Does that look like the one that we graphed? Yeah, awesome. Now, the other cool thing is that you can hit second, the blue button here, and hit graph again, and that's going to give you the table. See how it says table in blue? And there's your table of values. So let's scroll. There we go. So you guys see how this is where you see the symmetry? That's how you know your vertex is at 2, 5, which is exactly what we got. So you can always check your work by graphing this or by going to the table of values and checking the table of values, right? So you see the symmetry here. So these are the 5 points that we plotted.